Hey, hi guys, Shavik here. Welcome back to YouTube channel. So today we will learn one more like very important, So I have to say it's very important for all interview perspective. So it's another type of behavioral design pattern. So today we will learn state design pattern. So state design pattern actually that I already mentioned, it's also a behavioral design pattern. On our last video also we have discussed that chain of responsibility design pattern, which is also a behavioral design pattern, and state design pattern also a behavioral design pattern. So in behavioral design patterns is actually on high levels. It's mean when your object states, your object's behavior is going to be determined by the rules that you have written in your code, right? So on state design patterns, what we actually try to do when the change of every object's behavior, when it is going to be changed through some predefined state, then we definitely have to think about state design pattern. So with this video we will discuss the high level flow diagrams, how actually you have to represent the classes and the components when in an LLD interview, when someone basically want to dig deep on this particular topic of state design patterns. And also the very popular questions on state design pattern is ATM vending machines. So I think on our last video on chain of responsibility also we defined how actually the different money of denominations is going to be passed through different state. But today with this video we'll basically come to a more user interacting phase when let's suppose we are basically go to actually the entire user journey. So what I mean by actual user journey, so user journey is basically when you are entering in an ATM booth, then first you have to insert your card, then you have to enter the pin, and when your pin is going to be validated, post that you can do some X or Y amount of money to be withdrawn. Then that call is going to be went to our backend server, to bank server basically, which is basically providing the vending machines that information. So, okay, so this people is asking for this total amount, and to give him or her that much amount, we need X denominations of 1,000 rupees, Y denominations of 2,000, Z denominations of some 500, 200, like this. So that core logic of backend server, how basically the different denominations is going to be defined. So that is, I think we have already built that particular logic in chain of responsibility design pattern. So if you are going to face this particular things on an interview, that someone is basically asking to design that ATM vending machine, so first try to break down the problems, which particular things the interviewer basically looking for. Is the interviewer is looking for to define the actual denomination deterministic logic, so then you have to propose the chain of responsibility design patterns, how like different denominations the money is going to be debited, the notes basically going to be went out from the machines. And another component, how actually the entire user journey is going to be uh, fulfilled by the ATM vending machines. Then you definitely have to give the thought of state design patterns, how actually the state transitions in the ATM machine is going to be happen. Some state you are entering pin, some state you are basically entering the amount, some state you are basically inserting your card, and some state after successful transaction or the rejections of the transactions, you're basically ejecting your card. So there are different state the ATM machine is going to be iterate over you, so that it can fulfill your request. So you basically have to make your thought process very clear, which particular module is interviewer is looking for. And if interviewer is asked for, like if your interview is kind of a long duration time, like 2 hours, 3 hours, then I would suggest you definitely have to propose the both of them, the actual money denominations vending logic, and along with the state transitions. So on last video of chain of responsibility we have discussed the money denominations logic, and today we will discuss the state transitions. So if you missed that video, I will highly encourage you to go back to check on the chain of responsibility design patterns. You will get it to our playlist of our channel, the playlist of design patterns. You'll definitely get from there, and first try to iterate the chain of responsibility, then come to this video, then we will definitely get the code iterations part is going to be crystal clear to you. Correct? Okay, so with that note, we can start on the flow diagrams. Okay, so here we go, guys. So on state design patterns, let me just quickly check, is the recording is working fine? Yes, the recording is working fine. Can we start with the video? Yeah, so what actually we have to propose on a flow diagrams in state design patterns. So we already learned about on the introductions part that state design patterns is kind of a behavioral design pattern, when where basically we have to play the state transitions of the object based on certain rules, right? So now take the example. Now think of an example when you are basically entering to a ATM booth. So what actually the state? So let's suppose here I am. So let's suppose this is me, or I can, so let's suppose this is our actor, or our user. So our user, when basically he entered in an ATM machines, ATM booth. So what actually inside this particular thing. So this is our ATM machines, right? So let's consider this is our ATM machine. So in our ATM machines, in our ATM machines, what actually the things that you can think of in kind of a software things. So it should have a controller class. So on flow diagrams, we have to propose what actually the classes we can think of. What are the entities we can think of. So we definitely have something named as a controller class. So a controller class, what actually the method it could have, what actually the endpoints you can think of in user perspective. So we should have something like a start ATM. Start, how they can start the ATM by entering the cart. Initially our ATM is kind of an idle state, it is not doing anything. So when an user entered the cart, it's going to be invoked, and it's moved to like insert card state. So how to make an ATM from idle state to insert card state? By inserting the card. And how to insert the card, what actually the method, what actually the invocations, this in software terms the ATMs is going to be received, that is a start ATM call. So with the start ATM call, we should have a card details from the user. We should have a card details from the user. Now think about what actually the next state, what can be the next state. Then we could have after providing the after entering the ATM card to the machines, the machine is started, then they can provide the accept pin, then ATM can accept the pin. So pin can be a some kind of a int something, so some integer pin, right? Then what could we have? Then after accepting the pin, what else? Then we could have, sorry, there is a typo, this should be accept pin. Then after that, what could be the state? Then the state should be like what kind of request we should accept. It's kind of an withdraw withdraw amount. This is also kind of an int or long, whatever you prefer amount. You can take it. Correct. Else, what else? Then at any particular time, user should have the opportunity to cancel transaction, right? It should not take anything, so it should be able to cancel the ongoing transaction. Correct. On controller part, it's very straightforward, very clear, right? Now 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 think about, now you can derive your cart, like you can derive a entity of cart. It could be, why these are too big actually. This looks fine, this 14 is fine, not sure what's on the side. Then we could have a card class, right? A card, what are the fields you can think of? It should have a name, it should have a number, card number. What are the fields that we can think about? Number, then it could have some CVV, we can consider this as a pin. Then we could have something like known as expiry date. Correct. This should be more than sufficient for a card class. Agree guys? So we can propose this as a card entity. So this could lie to my inside my ATM machines. Now think about what could be the next entity. Now to take the request, we have a controller class. Now who is basically responsible to process it? We should have an orchestrator layer. We should have some kind of an orchestrator layer. So on orchestrator, this orchestrator, we can name it as an ATM machine orchestrator. Correct. Orchestrator. So it will basically take all the request from my particular controller to this particular ATM machine orchestrator. Now orchestrator is kind of, so this is actually the ATM machine's brain. You can say it's RAM, or whatever the processing logic is going to be stored inside this particular ATM machine orchestrator. So now state design pattern, think about what could be the states. So I can think about my ATM machines, so should have a some some generic state ATM state, I can say. So it's an interface. Now it should have multiple IMPL class. So let me just define what actually the method it could have, because every state should have a similar method, but for some state it's kind of a not going to be used. So that particular operations is not going to be permitted to the particular state. But on high levels, every state should have a same set of functionality. So what could be the functionality? The functionality could be same only when you are going to get a kind of a basically, what can I say, you are going to get a invoke like start ATM, right? Start ATM call. It's basically trigger the what it will do. It will basically start your ATM machine. By start your ATM machines means, so it should have some kind of a init ATM, correct? It should have a kind of an init ATM. Then what else? Then it could have some kind of a accept pin, right? Init ATM accept pin. Then it could have a kind of withdraw cache withdraw cache. Then it should have some functionality of eject eject card, right? Then what else? Then it should also give me a functionality of cancel cancel transaction, right? This could be the like state, like the method that I can think of my ATM, very generic ATM state should have. Now I have to think about what actually the state to permit these operations. So very start what actually the state at very start what actually the state of my ATM machines. I'm making them a little small because I'm not going to write the method here, because method we have already discussed on the interface. So our very start, the ATM should be at idle state. So here I'm just mentioning the idle state, and I'm mentioning that what happens. Command C, command B. Then what next state? What next state you can think of? Then we could have something known as insert card state. Insert card state, right? When after idle state, it should go to the insert card state for sure. For sure. Then what else? What else? What next? Insert card. Then we could have something known as cash withdrawal state. Cash withdrawal state. Agree? Cash withdrawal state, which is also going to be a kind of a ATM state only. ATM state only. Then we could have something known as eject card state. Agree? Agree. So the last one is going to be an eject card state. Eject card state. So these are like on high levels, we could have this many states, right? Now everyone is kind of an ATM state only. All are kind of an ATM state only. Correct? All are kind of my ATM state only. So this relationships, what kind of a relationships? This all are ISA relationships. This all are an ISA relationships. This all are ISA relationships. Let me just write these things also, because all are inheriting these particular things. All are inheriting these particular things from where they are inheriting, implementing. They're implementing from ATM state. So this is for sure. All are here are is a ISA relation. This all are ISA relation. We make the font little smaller. So this all are ISA relation. This is an ISA. This is also an ISA. This is also an ISA. And this is an ISA. This we can get rid of. So these are all ISA relationships. Now when my ATM machines is going to be started, when my ATM machines is going to be ATM, now all the state informations, whom should be aware of? My orchestrator. Agree? My orchestrator should be aware of all the ATM state. So can I say this all like idle state, or maybe I can write it in very simple. These are my list of state. So list of state means all the objects of this particular insert card, idle state, cash withdrawal state. All this information should be present inside my ATM orchestrator, because that is actually the brain. So it should be aware of all the ATM state present in our system. So this is a what can I write it? So this is a hazard relationships. What kind of relationships? This is a this is an hazard relationship. So here I can write it. This is an hazard. This is an hazard relationships. My ATM machine orchestrator should have all this particular state, all this particular state. Apart from that, what actually you can think of? What actually you can think of? What else? What else? Now, when a request of start ATM is going to be come from here. So what actually the operations we have to think of? So it should accept this particular start ATM call. So there should be a method of start ATM, and it should delegate these particular things to my interface of when there is a start ATM call. It basically internally should invoke my init ATM, init ATM, init ATM. It should invoke. Now on idle state, we should have something how actually the flow should work. So that I am basically mentioning. When at very start, when you got a call of start ATM, it should internally invoke the init ATM. Now you guys might have the confusions. Everyone's idle state, insert card state, cache withdrawal state, eject card state, everyone should implement as it's implement the ATM state. Everyone should have its like own logic of init ATM. But think about in terms of if everyone should have a which type of init ATM, which type of init ATMs everyone should have to perform. So on idle state, the init ATM, what operations we can do? We can set the card details, set the card details, set the card details, right? We can set the card details. But when already the ATM machine is in an insert card state, what actually you can think of init ATM? So it should not be going to be supported here. You should throw, if your state is insert card state and you are going to get a start ATM call, and on insert card state, if init ATM is going to be invoked, then it should throw something known as throw new some illegal argument, illegal args exception. Agree. Similar goes to the same story is applicable for these particular things also. Cache withdrawal state. Agree? On cache withdrawal state also, it's going to be useless because you are at cache withdrawal state and you are basically starting or invoking the ATM machine. So this is also not supported. So on idle state, what actually the support we have? On idle state, we actually have the support of init ATM only. Now on insert card state, think about on kind of a business perspective. Now on insert card state, what actually the functionality you should have to support? When card is inserted, then you can support of accept pin, but accept pin is not supported in any other. So on this particular state, you can support of accept pin, right? Again on cache withdrawal state, self-explanatory, we should support the withdraw cache. Here. I'm not going to write these things again and again. It should support the withdraw cache, and so this should have some concrete implementations. And if the call has happened for any other method of cache withdrawal state, then you should throw a illegal argument exceptions with proper some exception message. Now on eject card state, you should support like card ejections or whatever it's, and you should basically go back to your ATM machines to be an idle state. Set your ATM machine state to idle state, right? Now I think I have some space issue here. Let me just make it a little big. So now I am going to give you the overview of how actually the state transition should be looks like. So when you are at invoke ATMs, you are going to call the init ATM, and init ATM internally defined that we have to basically invoke the idle state. It is not going to be defined by interface itself. So here actually when start ATM bin is going to be when you are basically calling the orchestrator, and orchestrator is basically using the orchestrator has the knowledge of all the state, and it should responsible to trigger the correct state init ATM, right? Correct state init ATM method it should invoke. So how it is going to be know this? So this is going to be known by it should have a another method of or I have to say a value, a boolean object value of ATM state. So this basically tell this ATM machine orchestrator what actually the current ATM state is. The ATM is lying. So this particular ATM state is holding the value of what actually the current state of my ATM machine. So when at the very start of the day, when you are starting your ATM machines, you can start this particular ATM state value to be by default of new idle state, because ATM is an idle state. When it is going to be started the very first of the day, you can start it with idle state, right? And now on when you are at idle state and you got a call of init ATM, you set the card details, and Do we need to change the state? Yes, we need to change the state. We need to update this particular ATM state to be to insert card state. So how we actually do? So we don't have ATM. What actually we need? We basically need the ATM machines object, right? Because if we have the ATM machines orchestrator object, then with this ATM machine orchestrator object, we can call the set ATM state to be new insert card state. We can do that. Correct. We can do that. But we have ATM machines in our interface or any of the state? No, we don't have. So maybe now you can think of, then Shovik, let's take an ATM machine orchestrator inside my state. So please guys, focus on this particular point that we are going to discuss. So this is the most important, how we can actually remove get rid of the circular dependency, because now orchestrator we definitely need all of the ATM state, and now we are facing a problem. When we are at idle state, we also need the ATM machine orchestrator object. Agree, right? Because otherwise, how we are going to set the ATM state? When we are at idle state, after setting the card details, we have to change the ATM state to be an insert card state, but we don't have ATM machines object. So that's the reasons on every of this particular method, we are going to take this ATM machines orchestrator, ATM machine orchestrator orchestrator object as an input, because if we are going to take as a required acts constructor of a constructor initializations, then ATM machine orchestrator depend on ATM state, right? All the ATM state, and then again each of the ATM state is going to be depend on orchestrator. So that means it's going to become a circular dependency. So to get rid of the circular dependency, we definitely have to take my ATM machine orchestrator as a argument to each of them, to be argument of each of the particular method that we are supporting. So this is actually the beauty of this particular design pattern. So here you can see, although this ATM machine orchestrator has ATM machine orchestrator has ATM state, but implicitly ATM state also. So if I can make this a little big, so my interface of ATM state also, my interface of this particular ATM state also has ATM machine orchestrator as an object. See the beauty, right? See the beauty of this particular design pattern. My ATM machine orchestrator has ATM state, and my ATM state also has a kind of an implicit ATM machine orchestrator as a method argument, as a method arguments. Correct. So this is the beauty. So here you can see on this particular design pattern, we have a hazard relationships, we have implicit hazard relationships, and we have an either relationships. Now I can just quickly put the arrows off. So from very start, our ATM machine is an idle state. So from idle state, we are setting the card details, and we'll move it to insert card state because our card is inserted. Then from the insert card state, we should on insert card state, we should allow some accept pin. We should allow the accept pin. If pin is matched, then we should move it to cash withdrawal state. And on cash withdrawal state, if cash withdrawal done, so if cash withdrawal done successfully, then we can provide that many the informations that this particular denominations cash, we put that informations to our hardware, that x amount of x number of 500, y number of 2000 rupees you have to denominate to fulfill this particular customer request. That information, so we can give it to our hardware systems. But and also simultaneously, we should call our eject cards after successful transactions. Correct. So when we are going to call our eject card state is going to be invoked, and it will set our ATM machines, because on cash withdrawal state, your card is locked. You can't pull back your card from the ATM machines until its current ATM state is going to be set to eject card. So when your ATM machine orchestrator state is going to be set to eject card state, on that particular time, you can pull off your card from the ATM machines. And implicitly, when there is an eject card state, eject card method is going to be invoked, right? This eject card method is going to be invoked. You should set the eject card state, and eject card state should do an implicit set of eject card to idle state. After card ejections, it should set to my machines to be an idle state. Agree. Now on denominations, I think we have, on last video, we have built our backends of chain of responsibility, where a particular amount we are going to be asked from a particular clients, and that particular amount we are basically going to how many denominations we need to basically vend out from our ATM machines. That logic we have built. So this is we have built in our chain of responsibility. Chain of responsibility. This is completely a separate microservice. Chain of responsibility. Chain of responsibility. This is completely a different microservice. So from here on cache withdrawal state, we will basically build a web client. We'll basically build here and web client, or you can say a REST template. So web client is basically a kind of a currently REST template is usage is going to be suspended because REST template is going to be on maintenance phase. So if so on Spring we everyone is going to push us to use the web client. So here we have built our remote web client where we will call our chain of responsibility server to basically get the informations what actually the different denominations, what actually the different denominations of amount we have to vend. So this will give us the number of different denom notes ATM to vend out to vend out. So that information is going to give by a separate microservice. So this is, you can consider it a bank server which is going to take the responsibility of doing that particular job, right? So this is completely a different web clients we are going to get. So now there is one more like very very I have to say challenging things we have built. So this chain of responsibility we have deployed to some Maven Central. So if you guys know about like Maven Maven Central. So Maven Central is basically a kind of a remote repository where all of your jar is basically lying, right? So this we have basically deployed the jar to our Maven Central. We have deployed to this Maven Central, this chain of responsibility jar, and we are using to this particular new state microservice we are basically using in our pom.xml. We are in our pom.xml we are using chain of responsibility jar. That is our own jar we have deployed to remote. You guys also can use it. You guys also can use it. The chain of responsibility jar we have deployed to our remote, and we are using its all the model classes inside our state design pattern. Because when we are basically need to call this particular service chain of responsibility microservice, we have to build the request. We have our web client, but we have to build the request. Now request modeling, this chain of responsibility already hold, correct. So we can basically deploy it to a Maven Central jar, and we can use it to our state design pattern jar in our pom.xml of state design pattern, this particular microservice. Interesting guys, right? Interesting. So this particular remote deployment also we have done, but that mostly I will cover in some separate video, because otherwise it's this video is going to be kind of a like little distracted. If you guys are interested how to deploy your custom jar, your own jar to like remote repository, you can share this jar also to your friend circle, and play like uh, some mutual developments of this particular jar. You can show that you have deployed to some remote repository and use it when it's needed on different multiple modules, multiple projects. So these things also it's super duper exciting guys. So Maven, so you can just trigger a Maven deploy, and there is a jar is going to be deployed to your to the actual Maven Central remote repository. So that part also is going to be super interesting. So that I will mostly cover in some different video. So this state design pattern, so this particular server is basically running at port 8081. So this server is basically running on port 8081, right? This particular server is running to port 8081. Let me just big it. And this chain of responsibility is running at port 80 on my localhost 8080. It's running on my port localhost port 8080, and it is basically making a remote call to from this particular web client. It is making a remote call from localhost 8081 to localhost 8080. Correct. I will go with the detailed code walkthrough of this particular things. So stay tuned guys. You'll basically see how actually the state is going to be transitioned on each of the state of the user activity, on each of the state of the user activity. I will show you with the very detailed debugging of each of the individual lines use case. So stay tuned on the code iterations part. But on the high levels, I think this is actually the your entity diagram, or the class diagram, or a flow diagrams, whatever interviewer is looking for. You can explain this with this much clarity, and there is no chance of you are going to be rejected on this particular LLD round. So please, if on any part you have any concerns, just try to reiterate this particular part on which part you have need more clarity, and make a comments to our comment box also for same. So if you basically need some understanding, so we'll discuss on some separate video with detailed of that particular topic. Correct. Okay. So I will share this particular whiteboard also in the video description, so you can refer offline also to go through. So with this note, we can start on the code iterations part. Okay, so let's start on the code iterations part. So on code iterations, we can start from the controller. So on controllers, it's very straightforward. What we have just discussed to our flow diagrams, we done exactly same things. So we have a request mappings of ATM executions, and we have total four supported REST endpoints. One is like start ATM, another one is like accept pin, another one is withdraw cache, and the last one is cancel transactions, right? So let's go start with the start ATM. So before we do the start ATMs, I am just want to quickly give you the state that we have. So we have inside our business module, we have defined our ATM state. So on ATM state, we have primarily five methods that we have discussed: insert card, eject card, enter pin, cancel transaction, and request cache. So these are the five state that we have, five basically supported methods inside an ATM state. We in our generic ATM state, we have it. And every state, you can see that every method in our state is going to take ATM machines as an implicit has a. So you can see that every methods take as an ATM machines as an argument, right? Then we have our ATM machine. So our ATM machine should have to be aware of all the ATM state that we are basically want to populate. So because ATM machine should has all the ATM states, so that is an hazard. So this is informations of all the ATM states. Then we have ATM state, that is the current ATM state, and we are initializing it to of idle state for sure, because we on very start of the day we want to set our ATM state to be an idle state. Then we have the card informations, which is going to be set by default as null, amount is null, retry attempt it's 3. What is actually mean by retry attempt, we will come on this. Then we are basically setting our get ATM state map. I think we have already done to our chain of responsibility. We are iterating to our ATM states, and this ATM states is basically have all the objects of the state of defined state. It is the like beauty of Spring at that component annotations. When you have XYZ child class of a parent class of suppose A, and when we are writing of list of ATM state and we have a required tax constructor, Spring is going to be take care of injecting all of its different defined IMPL class to be set on this particular ATM state list. So now you can see that every of this particular child class has this component annotations at their component annotations. So Spring is basically creating the bean, and it is injecting to this particular list of ATM state. So with this map, we are basically creating a string. So it's a kind of an identifier, and we are setting the value to be the value of the map to be the actual object. So when we are going to call this get ATM state, so you can see that every state has its particular name. So that is, you can say, an identifier. So you have idle state, insert card state, eject card state, and cash withdrawal state. All the state has its respective identifier as a key and value as an entire object, right? So here you can see how we are building it. We are iterating to the object, and from the object we are calling the get state name. So it is basically giving its identifier, and the value should be whatever the ATM state we are getting. We are setting that particular entire object to be the value of this particular ATM state map, correct? Because when we are passing these ATM machines to define state, it will get the particular object it is going to be looking for, and it is going to set that ATM state to the that particular state object. So we'll come on this how actually this map is going to be used. Then what else? What else we have? We have start ATM. Start ATM is going to call the ATM state of insert card, because when we are going to call the start ATM call, it is basically an init ATM kind of things that we have discussed on the flow diagrams. It is basically set the card details. Then on accept pins, we are basically entering the pin, and on withdraw cache, it is basically doing request cache calls to our backend server to basically the state to basically the state, correct? And it is also doing like state transitions, because when your cache is basically successfully withdraw, then we have to move to our state to eject card state, and with the eject card we have to invoke our eject card to basically successful ejection of the card. And if there is any exception on the cache withdrawal part, then we have to do the same game. There is no fancy things we have to do. We have to do the same game, and on our money denominations object, what we are basically vending to the user, we can say that bank server is temporarily down, whatever the message that you want to basically give it, right? Then we have cancel transaction. So on cancel transaction also, based on that state, we are basically invoking the cancel transaction method of this particular state. Now we can quickly go to our cash withdrawal part, cash withdrawal state. What actually the business logic we have to our cash withdrawal. Maybe we can start with the as per the flow. So our first state should be idle state. Its state name should be idle state. what actually the method is supported on in idle state? Only card inserting is supported. So on card inserting on idle state, we are setting the card details to our ATM machines. ATM machines is coming as an object. I think you guys have already followed how we are passing the object to this particular as an argument to this particular method by passing this. So this means current particular object is going to be passed as it is. So ATM machines is the current class. When we are doing this, it is going to be passed as it is. Now on idle state, we are allowing to insert card, setting the card details, and we are we need to set our ATM state to be next state. What is the next state of idle state? It's insert card state, because card is inserted. So how we'll get the object of insert card state by calling this map to the identified key as an insert card state. We are calling its name. We got the object of idle card state. That is the beauty of the map that we have created in our ATM machines, and we are setting that ATM state to be idle state. We will see on debugger execution also. You will basically get the high actual like low levels, how actually the state is going to be updated. Then we are printing some message to the console. And now on other method, any of the other method is supported on idle state. Eject card no supported, no card inserted to eject. Enter pin not supported, cancel transaction also not supported, request cache also not supported. Correct, because ATM is currently on idle state. We only support to insert your card, not on any other things we are supported on idle card. Now after idle card, we should have insert card state. Now on insert card, what are the methods we have to support? Get state name, we have to provide an identifier to it. Insert card not supported, card is already inserted. Eject card, please cancel the ongoing transaction first, then we should be able to eject our card. First we have to cancel our ongoing transaction. So we are basically enforcing our user to first click the cancel transaction. Post that only we are basically support the eject card. Then on insert card, user is going to put you the pin informations. So we will check is our pin is going to be valid. How we are checking? We are basically checking our ATM machines of get card. From card we are basically taking the CVV, and we are basically checking whatever the pin is going to be provided by the user is matched to the current card CVV. If it is supported, if it is invalid, right, then we are allowing the client to do some retry. And how many retry attempts do we have? We have 3 retry attempts. Correct. So we are basically allowing our client to do 3 retries. So we are basically taking the current retry attempt. If retry attempt is less than 0, so we are basically triggering the cancel transaction implicitly, because client is exhausted of its retry and we are internally invoking our cancel transaction. So when our cancel transaction is going to be invoked, it basically setting our ATM machines to be eject card state, because card is already inserted. So we have to eject the card, and we have to trigger our eject card. We have to set the current state to be eject card state, and we have to trigger the eject card method, right? And we are basically giving the if it is inside the limit of retry attempt, then on that case we are basically allowing the client to do the retry with that many remaining attempts, and we are also decreasing our retry attempt count and throw some exceptions of illegal argument exceptions, that invalid pin something. Correct. And if it is successful, then we have to move our ATM state to be cash dispense state. Correct. Cash dispense state, we have to move it. Correct. So this is actually we have the operations in insert card state. Request cache not supported. Correct. On this particular state, insert eject card we have already discussed, should not be supported. Then we have cache withdrawal state. On cache withdrawal state, insert card not supported, eject card not supported, identified, so we are giving it. Enter pin should not be supported, pin already entered, processing cache withdrawal. Cancel transaction should support it to all the state, correct? Because on any state, user can trigger the cancel transaction only apart from idle state, because on idle state, first user should have to insert the card only after they can do cancel transaction, because transaction is altogether not started yet. But apart from that, all the successive state should have the cancel transaction, should have the common method. Same game to all the cancel transactions that we have already discussed. Now on request cache state, we have to call our backend server, bank server, to get the money denominations, which actually the money we have to vend out from our hardware. So we are setting our amount, the amount that the user want to withdraw, and we are calling our client. So this is the beauty, that here we have basically created our web client, and from web client we have built our URI. We have basically our this particular chain of responsibility. If you guys remember, it is basically running on if I can go to this money withdraw controller, it is running on /withdraw/money. So this is the endpoint we have to hit, which is running at port 8080. Correct. It is running on port, which port? 8080 port it is running. port 8080 it is running. So you have to hit it from our state design patterns, this particular microservice. So here the URI should be /withdraw/money. We are creating the request. To create the request, you can see we have taking this withdraw request. So you can see it is coming from io/github/99/chain of responsibility /1.0.4. So this particular state design pattern has a dependency of chain of responsibility, that particular microservice. We are basically taking this chain of responsibility as a jar. How it is coming? So now I can show you the beauty. So inside its form, we have our chain of responsibility as a dependency added. So this particular chain of responsibility is basically deployed to some remote Maven repository, and we are taking this, how we are basically taking Spring MVC Lombok as a dependency, Spring Starter Web as a dependency. Like similar way, we are taking our own jar, our own custom jar as a dependency to this particular state design pattern. And then we have this Spring Web Flux for by which we are building our Spring Web client that we are discussing here, that we are building retrieve, and if there is some 4xx, then we are throwing client error during withdrawal. If some server error, then we are basically throwing runtime exception of server error during withdrawal, as per the request that we are basically getting. And if all good, then we are giving this body to mono of this particular money denominations, and we are doing it to our caller method. But the beauty is how we are actually creating our request. We are basically creating our request from actually the chain of responsibility structure, chain of responsibility request structure. How we are able to do it? By taking chain of responsibility as a POM dependency, as an external library dependency. We are using this particular jar from the remote repository. Correct. So this particular things is actually new to us. Correct. Actually very interesting. Like when we are doing Maven deploy of chain of responsibility, a jar is going to be pushed from my local tools to Maven repo. And or like this particular project, I can use it to my n number of project that I want to use. So don't worry guys, if you guys are interested to how actually you can push your custom jar to remote repository, please do a comments to our comment box. I will be happy to take it to a separate topic to make a different video on this particular things. Then where we are at our cash withdrawal state. We got the response from our backend, and we are vending that particular information to our controller. Then we have the last state, that is of eject card state. So on eject card state, we are basically giving it the identifier as a eject card state. Insert card not supported, enter pin not supported, cancel transaction not supported, request card not supported. Nothing is supported, only we are doing the eject card. So we are giving the information, please collect your card something. Then we are setting our next state to be idle state, amount to be 0 because this particular transaction completed, retry attempt to be 3, and card details to be null because we are basically ejecting that particular card altogether from our machine, right? That is on high levels the thing should be working. Now I have defined this particular port, I have done port overriding, and I am running this particular things to be port 8081 because my chain of responsibility running at port 8080. Now few things that I want to show you, that ATM state configurations, this is not, we are not going to be, we are using, are we using it? No, right? I think so we can delete, it's safe to delete. I can delete this particular class. Then we have web client config. So on web client config, you can see that we are creating our web client beans with some connections timeout, with some response timeout, blah blah. So these things, take it as an abstract thing. So if you guys are interested how actually you have to build your web client, so I will basically explain in details on each of the parameters that we are using. But for this particular video, maybe take it kind of a black box. So we have to build our client to make a REST call to our bank server. So our bank server is basically giving us which of the denominations, how many count of the denominations money we have to withdraw, correct? And we have provided our base URL as localhost 8080 because on that particular port our chain of responsibility or the bank server is running. Clear? Very simple, very simple. Now we can start our server and see the beauty. We can start to see the beauty. I am starting our server to be on debug mode. Let's see. Okay, so Tomcat started at port 8081. I'm starting this particular server to be 8081 and chain of responsibility running at port 8080. So now we can start to invoke our ATM machine. Let's start with some dummy informations, correct? So we hit it. So call comes to start ATM. Now if I'm going to see the what actually the state currently it is holding, you can see it is holding idle state. It is holding idle state. So inside my this, what actually the state inside my ATM machines, what actually the ATM state, the current ATM state is idle state. And what actually all my ATM states, you can see all my bins, cash withdrawal state, eject card state, idle state, insert card state, all the states information ATM machine is holding, and the current state is idle state, right? Go further. Now it is basically come to the insert card method of my idle state. It will set all the details. It has set my card details. You can see my card details are set to my ATM machines. If I can show this method of my ATM machines, inside my ATM machines also you can see my card details has set successfully, and my state is going to be changed from previously. When previous of this line execution, my state was what was it? It was idle state. But now you can see after this line execution, line number 24 execution, my state is going to be updated to be insert card state. Now we can go further. Application is running on Postman. We should get 200. Okay, our ATM is started. Now when my ATM is started, without pin enter, if I am trying to do withdraw cash, see, let's see what is going to be happen. We have hit it. My inside my ATM machines, what actually the state it is, it's on insert card state, but we are trying to withdraw. See, let's see, call goes to my eject card state. Call goes to my eject card state. How actually it goes to my eject card state? If I can try to backtrack it. So from this cash withdrawal state, cancel transactions, insert card state, ATM machines should cancel transaction, insert card state. Okay, ideally what we were expecting, it should land to my cash withdrawal state, not this. It should land to my insert card state ka this particular line, cash withdrawal. So it should land to this particular method. So if I can trace back the call, let me just run it. So my current ATM machine's state is going to be on eject card state. Why it has happened? Request cash on idle state, then eject card, then application is running. What actually happened here? Okay, bank server is temporarily down. It is giving me this message, bank server is temporarily down, because okay, I got the issue. I think what has happened on my ATM machine, when it is basically hitting this withdraw cache, when I'm going to hit it this withdraw cache, it's basically take these arguments. So if I can put the debugger point here, so you guys can see it, it is basically calling out withdraw cache to to that particular things, withdraw cache to, it will basically try to call my, it will basically set my state to be this eject card state, and it is basically going to call this eject card state ka request cache. So that's the reason it's the caller is moved to be on the eject card state. That's the reasons. Maybe I can make it a little simple. I will handle these things later. So I can just, what actually we are looking for, we are basically looking for ATM state dot request cache, and we are passing whatever the amount we have and whatever the this we have, correct? So these things we can do a hot reload, hot swap we can do. Let's see if it is successful. Okay, let me restart the server. Why actually what is missing? What happens? Why actually it is showing this compilation error, Java missing? Okay, we have to return the things, then we can try a hot swap. Okay, hot swap successful. Then on withdraw cache, we can add some kind of a try catch, validate ATM machines dot, this is wrong altogether, but let's take it. So it can give me, it can, we have to call the withdraw cache method, and if we are going to get, so if I can go to this and make it void request cache. Okay, I think I got it. Cache withdrawal state, it can throw my exception, illegal argument exception. If there is something error to my server, then we can use this to my response entity dot okay, we should be able to pass these particular things, or if it is not, then we can give some message, bad request, illegal argument exceptions to be fail to withdraw amount, fail to withdraw amount, something like this, correct? And here also we can give bank server temporarily unavailable, right? This kind of message we can give here for sure. We can give it, now it's a string, so we can make it a generic. It should work now. Remove redundant arguments of bad request. Okay, bad request should be fine. We can give it some body to be this response entry dot bad request dot body. We can give it some body to it. Withdraw. Similar things we can give it to this internal server error dot my body to be this, and we can remove this build from here. Looks good. We can do a hot swap now. Still one error. What actually the error? Catch, try this particular. If it is all kind of exception, then it should catch all. Okay, sorry, I think we have go down the previous go only. We are not returning from here. That is the reason it is giving us the compilation error. Give me a successful hot swap. Okay, now we can start our ATM machines again. We can start our ATM machines, the same game that we are trying. And this we have already went through. Our ATM machine state is idle state. Now it should go to change to, it should be going to be changed to insert card state. I just not want to basically reiterate. Then we can go to our withdraw cache. Now let's see what is going to be happen. It's, let me see the ATM machine's current state. It on insert card state, and on insert card state, when we are going to hit the request cache. Now this is actually the debugger point that I want to show you. So on insert card state, can I basically ask for request cache? No, only supported one is the two supported cancel transaction in all state and accept pin, right? Request cache you can't do. Now you can see calls come to here. Now if I can go further, exception should be thrown, fail to withdraw amount. Why it is so? Because now just now we have done here that if it is throwing an illegal argument exceptions on controller layers, if it is an illegal argument exceptions, fail to withdraw amount, we have basically putting, or maybe better to, we can put something like exception dot get message. That seems to be more generic, right? Then we can see what actually the message we are getting. Similarly, we can do for this also exception dot get message. We can do an hot swap, and we can basically trigger this call altogether. Hot swap done. Then we can again try to do the same call. Request come to idle insert card state ka illegal argument exception request cache state. Go further. Exception should be now throw with the proper message. 400 bad request, please enter pin before requesting cache. So you are trying to do a bad request because you first have to enter the pin before requesting cache. And from where it is coming, if you guys saw the debugger points, it is coming for please enter pin before requesting cache. That is of insert card state ka request cache method. In insert card state, you can't request cache. Now go to the flow by flow. Now we are trying to put the pin correctly. Now in our CVV, we are basically putting, if you guys remember, our CVV is 199 and we are putting that pin only. Now our ATM state is insert card state only, correct? Insert card state only. And on insert card state, are we able to put the pin? Yes, that exactly we are looking for. Let's see. It's come to the accept pin state, and what is the actual state it currently has? It's on insert card state. Now go further. Yes, on insert card state, we have a concrete method of enter pin without no exception. It is the supported method of this particular state of insert card state. Now we can go further. Validation pass, pin matched, correct? Pin matched, not an invalid. So call didn't move it to this particular block because it's not an invalid pin. Is valid pin not So is it an invalid pin? Then only it is going to be executed. So call directly comes to here and it is going to set my ATM state to be cash withdrawal state. See, current ATM state is insert card state, correct? If I can scroll a little up, so current ATM state is insert card state. After this debugger, after step over, just focus on these particular variables. It is bound to be get updated to be cash dispense state, cash withdrawal state. Go further, ATM state is going to be updated. You can see this blue line, ATM state is going to be updated to be cash withdrawal state, correct? That is the expectation we are looking for. And also pin accepted, pin is accepted. Now if we are going to try to withdraw the cash, which is going to be giving us 400, with first entered the pin, now we have entered the pin, now our ATM machines has the informations, the pin is going to be accepted. Now it is only allowing to me to withdraw the cash. Call it my ATM state is ATM, inside ATM machines the ATM state is cash withdrawal state, exactly the state that we are looking for. Go further. So now you can see on my cash withdrawal state, the request cash method is going to be come to the exactly the cash withdrawal state. Now if I can go further, it's come to my client, it will now try to make a backend call to port 8080 where my bank server is running or chain of responsibility is running. So let's see, it's made a call, everything is fine, application is running, it's made the call, it's got the response. Now you can see call has come to here, so that means my server call is fine, it's still on the try block, it's come to not went to the cache block, and we have still this withdraw cache. Now if I can go further, it's come to the controller, and if I can click on this, it is working exactly fine, now on this particular place also, on Postman also, you are going to get the information that dispensing completed successfully. These are the state, these are the amount that we have to basically vend out. But let's suppose for an example, if the transaction is going to be not going to be successfully completed, let's suppose how we can achieve this. Let's suppose we are going to make our bank server, that is chain of responsibility, which is running as port 8080, we are making it down. So now if I am going to hit to my withdraw cache, let's see what is going to be happen. Call comes to hit exactly same path, cash withdrawal state, correct? Cash withdrawal state. Now if I can go further, fine, we are trying to make the client call, so we are expecting it should come to the is 5xx server error, because server error during withdrawal, because server is down, bank server is down currently. See the flows. Now it will going to try to make a backend call. It's tried to make a backend call, and we are at catch block. You can see the exception come to here. Connection refused. No further informations from localhost 8080. Detailed message. What is the message? It's give us, and on the cause also we can see connection refused for port 8080, because port 8080 is currently on port 8080. We don't have the backend server running. Now if I can go further, the same exception should be went out to cash withdrawal failed, ejecting card, and your card should be ejected out. I think that functionality I'm not sure is going to be implemented or not. Let me check. Ejecting card, error during ejecting card. I think we have to add it. So on withdraw cache, if it is going to get an exception, illegal argument exceptions or response entity dot bad request, whatever the exceptions it is going to get, we are basically here. It is very simple, like maybe with the ATM machines all together, you can just trigger the because now you have to move your ATM machines to be ejecting card state, otherwise the card is entirely blocked for the user, which is currently happening, right? Because the ATM machines is not moving to eject card state, it is just giving the message. So I think our call has come to this particular block, or which block, let me just quickly check. Is it an illegal argument or runtime exception? If you guys remember it, on cache withdrawal state, it's showing illegal argument exceptions. Go back. So on illegal argument exceptions, I'm just adding it. So we are going to trigger our ATM machines. What actually the exact functionality of eject card state, we just have to do the same things. So set ATM state to be ATM machine get map get whom I am looking for my eject card state dot name. I got my eject card state. We are importing that our eject card state. So my state is going to be set, and I am going to invoke it. ATM machines dot eject cart. What is the method we have? ATM machines dot cancel transactions, or let me just quickly check it. We can call this eject cart, right? We can just call this eject cart with the state that we have stored. So we have updated our state, so we can get the ATM state, and when we got the ATM state, we can call the eject cart, and inside that we can pass our ATM machines. Correct. So now if I can go back to my eject cart, what is the implementations we have? So it should move to my eject cart, and it will basically setting my ATM machines to be an idle state, right? On idle state. Otherwise, what actually currently happening? So if I am going to start my ATM after it is not able to emit or eject the amount, or vending out the amount, ATM machine is not going to reset, right? My card is going to be stuck on the ATM machine. I am not able to eject my card, so it is still stuck on the cash withdrawal state. Now if I'm going to start my ATM machine, so let's suppose this particular user's card is going to be stuck on the ATM machines. He or she is not able to eject the card, and let's suppose on new, nothing is going to be supported, right? Because your card is going to be stuck on the ATM machines and backend server is down. So if I'm going to hit a start button, so you can see my ATM state is still on cash withdrawal state. ATM state is still on cash withdrawal state, right? Cash withdrawal state. Now if I can go further, on cash withdrawal state, you are trying to insert the card. It is throwing an illegal argument exception. Card is already inserted, and you are trying to start your ATM machines. It basically throw an illegal argument exceptions. Now if I am going to add the debugger of this particular controller, so the new code that we have just added, it I am going to get a call at here, right? Sorry, not here, sorry. So we are going to get a call at runtime. Illegal argument exceptions is kind of a illegal, it is kind of a runtime exception for sure. And you can see that I think I am expecting a 500 only, internal server error only. If I can go further, 500 only, card is already inserted, that information now. But what actually we are looking for? Wait, so a new user is not actually start the ATM machines because card is already stuck. But but now, as the new functionality we have already added, if I'm again try to do the withdraw cash with my bank server as down, previously it is not basically making resetting my ATM state, right? Not resetting my ATM machines. My ATM machine should move to the idle state so that it can eject the last user card, and it should accept new user, right? For that particular user, is it's not able to withdraw the cash, but it should not block the ATM machines altogether. It should reset to the idle state, which functionality we have just added. Now see if I can go further, it's still on the withdrawal cash, money withdrawal. Go further, it's on the client call. It should fail. Application is running. Cash withdrawal failed. Ejecting card. I'm not sure why debugger is not went there, but let me do a start ATM again. Let me check if my state gonna update it or not. No, it's still not updated. What actually went wrong, guys? What actually went wrong here? It's still on cash withdrawal state, but we have basically added the catch, right? We have added the catch here. If it is an illegal argument exceptions, it should reset my ATM machines, but why it's not gonna execute this? Let me just resume this particular application, because we know this is altogether going to give 500 only with card already inserted, that we know. Now let me just retry why the new functionality did not work here, that I want to understand. Next debugger point, then I should put a debugger point here. This fine. Okay, now backend server is down, same exception. Connection refused for 8080. Now I just want to see what actually the calls is going. This fine, we are throwing an exception, and it is coming to this particular new code that we have just written. So now why it is not coming this particular catch, as it is an illegal argument exception? Why it is trying to trigger this particular block? it is giving us cash withdrawal fail ejecting card, the 400 ones. The 400 ones it's giving, but it is not basically coming to this particular block. It's strange actually. Response entity dot OK, return response entity, bad request, body exception dot get message. It's doing all the things. ATM machines dot set ATM state. Why this line not going to be executed? But if it is also a successful transaction, right? So then on that case also, like if it's an withdraw cash state and we got any kind of exceptions here, right, then on that case also we should do the resetting. There is no doubt here. And on this particular case, if any other kind of exception also, then also we should do the same things. Let me just check why the calls is why this not resetting of the ATM machines is not happening. It's directly giving me 400 or 200, whatever it is. So let me just retry. Okay, it's currently on eject card state. Okay, it's currently on eject card state. Let me go further. Illegal state. So now you can see it's coming to this particular withdraw cache. Illegal argument exceptions. No card inserted, but it should not be this eject card state. Then my ATM is running and it should set the idle state. So let's just run the entire game again. So we are basically starting our ATM just to basically recap the things, how actually we are expecting the things. Here things should be good, nothing fancy. We should got a 200 okay here. Then we are accepting our pin with the correct pin. Correct. Let's go. This is also fine. Our pin should be accepted. Then we should enter our withdraw cache with backend server is unavailable. Correct. So it is directly moving my call to eject card state. Why this is happening actually? These things is not clear to me. It's coming from cancel transaction only. How it is moving the call entirely to be this particular things. So my ATM controller dot set eject card state, that is the like half. Oh, okay. So we are setting it before the call. So which is actually problem, no guys? So we are basically, so this is a wrong things, no? So we can't set after execution only. We should have to set it, which is wrong. Response entity dot. So this looks good to me, but this we can't do, right? Because if exception has thrown, then only we can do this. This is fine. We should do it here, and we should store my response entity of something to be as a response, and we should return our response finally. This should be the case, return our response. So that is a bug. Now maybe it's going to be on eject card state and my ATM is going to be resetted. That is fine although, and it should move actually to be an idle state. No card inserted. Okay, so let's try. Maybe we can go a little fast. It's fine. ATM started. Pin exception. Pin is also accepted. Withdraw cache. Withdraw cache of whom? ATM machines of withdraw cache. Exactly what the call that we want to see. So fine, it's on withdraw cache. Now it is making the client call. Client is down. Call came to here. Still fine, no issues. Now you can see that this particular code block that we want to see is going to become call comes to here. Now on controller, you can see on withdraw cache, we got illegal argument exceptions as cache withdrawal failed ejecting cards. That is our backend server is down due to that reasons. Correct. Now go further. Now you can see our ATM machines is also going to be reset it. is also going to be resetted. It's currently on cash withdrawal state, right? It's currently ATM state is cash withdrawal state. But after this line execution, my ATM state is going to be set to eject card state. Now, inside that eject card state, now we are calling from this eject card, we are going to call the eject card method. Now, inside the eject card method, we are going to set my ATM machines to be idle state. Now, see, it's on eject card state. After execution this line, it's an idle state, so ATM is going to be resetted, and all the variables lying to my ATM machines is also going to be resetted, right? So that exactly we are want to see. Application is running. Here we are getting cash withdrawal failed, ejecting card, and your card is also going to be ejected successfully. How I am ensuring this? Because your ATM is going to be go to the idle state again. Now, if I am going to hit, so on last time you remember, right? Your ATM is lying on cash withdrawal state and you are not able to start your ATM machine. But this time, can we do? It's its idle state, and we got a call of start ATM. Move further. Insert card is inserting. We are getting the card insertion details. Is it 200? Okay. Yes, it's 200. Okay. And on also accept pin. If everything is fine, on accept pin also, it is also accepting your pin also. So your ATM is correctly resetted. Now, if I am going to start your backend server, now on port 8080, and now you can see that after successful withdrawal also, your ATM is going to be resetted. That is the expectation, right? Because when you have done maybe your transaction is going to be failed or your transaction is going to be succeed. No matter what, your card withdrawal should happen. You should be able to eject your card. Now, if I can go to our postman and our backend server is running fine. We are trying to do the withdraw cash. ATM state is cash withdrawal. Looks good to me. This call should not come to now the cache block. Call directly come to the eject card method. You can see call directly come to the eject card method. So that means after successful transaction also, your ATM machines is doing the resetting. ATM state is going to be resetted. ATM state is currently idle state, right? And all the variables are going to be amount reset. Card details also going to be resetted. Retry count resetted. Card details also going to be set to null. And if I can go further, on postman also we should get a 200, okay, with some response that this money is denominated. Yes, 1001, 501, 201, and message dispense completed successfully. So either your dispense is going to be failed or dispense is going to be succeeded. Your ATMs is going to be moved to the idle state because on the new logic that we have to written over our controller class that we just did on ATM controller. On withdraw cash, either it's a succeed or either it's a failure. Your ATM is going to set to the eject card and idle state basically. Correct. So I am not going to do the cancel transaction. So on cancel transaction, I'm just doing the code iterations. There is nothing on the cancel transactions. Everyone is doing the same things. Or maybe if you guys want to see, then I can show you every method. If we are setting our eject card and we are calling the eject card method. So maybe I can do a quick demo of this. Maybe we have just started our ATM machines. Correct. Application is running. So ATM started. Now let's suppose if you want to trigger the cancel transaction. So insert card state ka cancel transaction method is going to be invoked. So our ATM state is insert card state, and on insert card state, whatever the cancel transaction, now cancel transaction method is common for all. So it is going to set my ATM state. Current ATM state is insert card state. It's going to set it to eject card state, and it is going to call the eject card state ka eject card method, right? Now we are going to get on the eject card, and on eject card, if it is on eject card method ka eject card state, it is going to set my ATM machines to be idle state. It set it, and it will do resetting of card, amount, all the details that we have. It will going to reset. Card details is going to be resetted. Will going to reset. Amount is already resetted. Retry attempt is resetted, and card details finally resetted, right? And you can get a 200, okay, transaction cancelled. Your transaction has cancelled. So this is like common for all the state. So yes, guys, that is on the high levels how actually your ATM state design pattern is working. So this kind of like video is actually need in-depth preparations and very good like dive deeps we have to do before making such like LLD or HLD kind of design patterns. And if you guys really find it helpful, please share the videos to your friend circle. And if you guys have any thought of any points that we can improve or any kind of any questions or any clarifications you need, so please put your valuable thoughts on our comment box. I'll be very happy to answer those. So that's it for this particular video guys. Let's meet with another video with another beautiful topic. Okay, that's it guys, that's it for this particular video. See you, bye bye.